Okay, y equal 5 cosine theta. We're going to go ahead and graph these. We're going to state the amplitude and period. We're going to label the axes appropriately and sketch the graph. Okay? All right, so look. Remember, it is y equal a amplitude cosine bx, and then of course plus c plus d, or actually minus c, whatever. Okay, your amplitude here is 5, so that's our max min. So as we're graphing it, since it's a cosine function and it kind of does this, right, up and down, the high, because we're still at 0, we have not vertically shifted, meaning raise it high and low. Our amplitude is going to be at 5, -5. That's it, okay? That's all amplitude does. It's the high-low. Okay, what's our period? We have not shifted period, but your period, to calculate period, traditionally it is 2 pi, which is 360, and you divide by the b value. Okay, why is it 2 pi? Because, that's not what I want to look at. I don't know. Oh, the reason why a period is 2 pi is because when you start at 0 and you rotate or spin around, right, all 4 quadrants, it's 360 degrees, which is 2 pi. So that's why 1 period is 1 spin, okay? So if you ever want to change the period, find out what the b value is, divide that into 2 pi, what you get is your period. Okay, my b value is 1, right? Because there's no number here, it's just 1 theta, or 1x, right? So what's 2 pi divided by 1? Just 2 pi. That's it, okay? So for my x-axis, it's just going to be pi over 4, pi over 2. All right, so how do I work with these? Graph paper, we're just going to use icky graph paper. All right, fractions. Okay, I want my first tick mark to be pi over 4. So I want to count my x-axis by pi's over 4. So this is 0. My very first one is 1 pi over 4. So then what's the next one? 2 pi over 4. You're going to count 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay, this is 1 period. Okay, now, how do I know to stop at 8 pi over 4? You guys should be able to reduce, and so when you are looking at this, radians, why are there 3s and 4s and 6s and 6s and 4s and 3s? That's because you should know how to reduce. So pi over 4 is pi over 4, but what's 2 pi over 4? Pi over 2. 3 pi over 4, what's 4 pi over 4? Pi. 5 pi over 4, what's 6 pi over 4? 3 pi over 2. 7 pi over 4, what's 8 pi over 4? 2 pi. So when you guys have to understand, when you're looking at a graph, they're always going to reduce or simplify your radian. But you just have to know you won't get docked. If you give me this on your graphs and you don't do the pi over 2 or pi or 3 pi, as long as you know how to look at a chart and read that, but just be careful. Okay, I'm going to transfer that over to my graph, okay? So I'm going to drop it. Pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and there's my 2 pi. So if I want 1 period, this is a period, 0 to 2 pi, right? And it goes for 5s or 6s or 3s or 2s. That's it. Just count the numerator. It goes up by 1 unit, or 1 pi. Okay, so now So now here we have, let's try and find my values. All right, we have the cosine function. All right, but here's the thing. Because it's 5 amplitude, it's not 1, it's 5, right? It's not 0.87. Where's my calculator? It is, what would I do? What do I do to the 0.87? Perfect. So it won't be 0.87. I'm going to go times, and I'm going to get 4.35. Okay, so if we start graphing, or rather, if I times 5, this is going to be 5. Do we do them all? I'm only going pi's over, I'm only going to do the pi over 2, so let's do this one. Okay, pi over 4, so it's not 0.71. It's going to be 3.55. So this one will be 3.55. Pi over 2 is 0, so that'll still 0, because what's 5 times 0? 0. Next, 3 pi over 4. It's not negative 0.71, it's negative 3.55. Pi is negative 1, that's negative 5. 5 pi over 4, negative rad 2 over 2. So this is negative 3.55. 3 pi over 2, 0, 0. What am I doing? 7 pi over 4, 3.55. And then 2 pi, 5. So those are the numbers I'm going to be plotting. Okay, here's another thing. As far as your calculator, we took the chart, because obviously we want you guys to build confidence in the chart. But if I'm in radians, I still know if I'm rushing. Do I wait here? What time is it? Flashy. Yeah. I'll wait here, because I'm going to show you guys.
I got a crazy